In this video, we will learn how to calculate Young's modulus of the material of the bar by non-uniform bending by using single optic lever and scale and telescope to measure the depression. So these are the experimental readings. So look at the first reading. For the dead load, for loading and unloading, it is 23.3 and 23.5. So the mean is 23.4. And for W plus 50, it is 27.4 and 27.2, and the mean is taken 27.3. And for W plus 100, W plus 150, W plus 200, 250, 300, the corresponding mean readings are calculated. Now we need to find out shift now. To calculate the shift can be calculated for 200 grams, 150 grams, 50 grams. It is up to us to decide for what mass we are going to find the shift. Here the shift is calculated for 200 grams. For this, what we have to do is, take these two readings, W and W plus 200. These two readings are highlighted in red here, and the corresponding mean values are subtracted with each other, and the answer is 14.25. For the next set, the shift for 200 grams, the readings are W plus 250 and W plus 50. So 41.55 is subtracted with 27.3, which is highlighted in green color, and the corresponding shift is 14.25. Next shift for 200 grams is W plus 300 minus W plus 100, which are highlighted in blue color, and the respective mean is subtracted, and the answer is 14.45. And the next shift is W plus 350 minus W plus 150, that is 48.6 minus 34.25, and the result is 14.35. So we got 4 shift readings for 200 grams of mass. So all these 4 readings are summed together and divided by 4 to get the mean shift as 14.325 into 10 power minus 23 meters. The next is breadth of the bar. The least count of the vernier calipers is 0.01 into 10 power minus 2 meters, and the error here is nil. The first column represents the main scale reading, second column represents the vernier scale coincidence, and third column is vernier scale reading, which is calculated by vernier scale coincidence into least count, then the next column is total reading, which is an addition of main scale reading plus vernier scale reading. So the main scale reading in the first reading is 2.6, the vernier scale coincidence is 8. The vernier scale reading is obtained by multiplying vernier scale coincidence into least count, that is 8 into 0.01, that is 0.08. So the total reading is 2.6 plus 0.08 is 2.68. So the mean breadth is calculated, and which is 2.668 into 10 power minus 2 meters. Next is thickness of the bar, which is found using a screw gauge, and the error here is positive error of plus 3, so the error correction is minus 3 divisions. The pit scale reading and the head scale coincidences are tabulated here. From this, the mean thickness D is found as 4.818 into 10 power minus 3 meters. The other parameters are also measured, that is the distance between the two knife edges here is 60 centimeters, that is 60 into 10 power minus 2, and the distance between the scale and the optic lever is 90.5 into 10 power minus 2 meters, and the perpendicular distance between the forelegs and hind legs of the optic lever is P equal to 4.6 into 10 power minus 2 meters. Now let us calculate Q. So the formula to calculate the Young's modulus of the material of the beam by non-uniform bending and scale and telescope and optic lever is Q is equal to mg L cube D divided by 2p D cube S. We know m, that is the mass for which the shift is calculated, that is 200 gram into 10 power minus 3. Then gravity G, it is 9.8 into L is that 60 into 10 power minus 2 the whole cube into 90.5, that is the distance between the scale and the mirror, divided by 2 into 4.6 into 10 power minus 2 into 2.668 into 10 power minus 2 is the breadth, and the thickness is 4.818 into 10 power minus 3 the whole cube into 14.325 into 10 power minus 2. First let us club all the numbers on the powers. So 200 into 9.8 into 60 power 3 into 19.5 into 10 power minus 3, 10 power minus 6 and 10 power minus 2. So in the denominator we have 2 into 4.6 into 2.668 into 4.818 the whole cube into 14.35. The powers are clubbed here, 10 power minus 2, 10 power minus 2, 10 power minus 10 and 10 power minus 2. So in the next step, all the numbers are multiplied. So when you multiply all the numbers, we get 3.831408 into 10 power 10. So students, most of you miss the exponential power when you compute it using a scientific calculator. So you will get 10 power the exponential of 10 to the power 10, and the other powers minus 3, minus 6, minus 2 will give you 10 power minus 11 divided by, when you multiply all the numbers you will get 39,324.994, and you sum up all the powers you get minus 2 is minus 4, minus 4 minus 9 13, so minus 15. In the next step I have brought the 10 power minus 15 to the numerator, so it is 10 power 15, and 10 power 10 and 10 power minus 11 will give you 10 power minus 1. Next let us divide these two numbers. When you divide, what you will get is 9.724 into 10 power minus 5. This is what you will get it in the calculator, 9.7424 into 10 power minus 5. Then this 10 power minus 1 and 10 power minus 15 in the previous step will give you 10 power 14. So in the next step it is 9.7424. This 10 power minus 5 and 10 power 14 minus 5 plus 14 will give you 10 power 9. In the next step, you bring a power inside so that your Q becomes 0.97424 into 10 power 10 Newton per meter square. So this is the expected value of the Young's modulus of the material of the bar by non-uniform bending method. So usually the Young's modulus will be in the power of 10 power 10. So the difficult part in calculating this is for the students is to get the power right.